Yeah, reminder as usual, especially for your project milestone 1, I would like to speak a little bit more about it just in the beginning of the class. All right, by the way, your assignment 2 has been released. It will be due not next week, but the week after. Just check your calendar, okay, just for submission. And I want to talk about your project milestone 1. And thank you for everybody for signing up for the Google Sheets. It's almost like buying a concert ticket. Within 5 minutes, all the slots are gone. Awesome, I like that, okay? We'll do the same for milestone number 2, okay? Okay, and, okay. You know, I really try to do as fair as possible because the earliest group will be like a Wednesday morning. The latest group will be like a Thursday afternoon. So I really don't want to have, different submission deadline for certain stuff. Why don't I set a cutoff deadline before the very first meeting for everybody, just to be fair. But milestone number 1 and 2 are really meant to push you to make the minimum progress. So I don't think it's going to be an issue. And I'm going to release a PDF guide detailing exactly what I'm going to say. Okay, everything's going to be consistent. I just want to let you know beforehand. You will need to submit whatever source project you have by using the submit command. And I'm going to give you exactly the command tonight. Okay, by 11:59 p.m., basically midnight on Tuesday. Okay, so every group have to make sure you submit your stuff, and then that will be for evaluation. And I'll talk about more about what you're supposed to do for milestone 1. I can refer to the project description. Bear with me. And basically, you also need to include a very simple README file just to let me know, because I will be the person to share the screen and also to run your tool just to make sure your example files really work. If I ask you to submit 3 example files, I'm going to try only those 3. I'm not going to try any other input. I might just make some suggestion, but it will be just mainly to give you feedback. You might tell me that, for example, to use your tool, I need to say Java minus jar, compiler the jar, right? The runnable jar, basically. And then you can take 1 argument or 2 argument or more. It depends. It's completely up to you. But you got to let me know. And also, once I run this command, where am I supposed to find out the HTML file? Did you name it, for example, index.html, or did you name it something else, right? Again, that's your freedom. And the example files, they should really work. If I try to run your runnable job built on your projects, they should work. They shouldn't crash, okay? And I will share my screen to build your project, and then I might just also take some time, if time permits. I can go over your code a little bit, ask you guys how you have been doing, and give you some feedback. I think that will be going to be valuable for you to move on, all right? And up to 30 minutes, no more than that, okay? And for milestone number 1, okay, you're going to give me 3 example runs, so that means 3 example files, right? And then you're going to cover not all of them, but you should cover at least some of the basic programming components. How you declare module, how you declare variables and assignment, etc. So that's kind of similar to what we have done for your tutorial and also the practice test. And for the output, we should really expect to see 1 control flow coverage and also 1 data flow coverage, at least 1, right? If you want to do 2, that's okay. I just need to see 1. Just make sure you're okay. I might ask you guys some questions related to your design work implementation. Please just get ready, okay? And then I think that's about it. So you can definitely expect a PDF file from me either later tonight or early tomorrow, the latest. I will outline exactly what you have to submit. And then just make sure you submit it by the deadline, okay? Do you guys have any question about milestone number 1? I hope that's clear. Okay. Again, it's only 1%. It's mainly just to push you to really get the smallest unit work, as soon as possible, so you can move on with the more advanced stuff later for higher marks. Okay. And there's one more thing I want, which I forgot to mention last time. I want to point out to you the source you want to look at for sure to prepare for the later assessment. If you go to the lecture site, I actually posted the source code for both the composite pattern. You can see under the code section here, composite, and also visitor. The composite one is rather straightforward, but you should really go over just to see if there's any part you might need explanation. But the visitor pattern here, I want to mention 1 thing. Once you import the project into Eclipse, you will see we got operations package, we got operations package, we got structures package. You got to study them. That's what we have went through in the lecture. But I want you to look at this particular one, the JUnit test. Okay. Okay, I wouldn't go into detail, but I just want to point out to you. I want you to look at this section over here. This section here is really about checking that the composite tree that we have built has the expected structure. And I want you to ask yourself, why is typecasting over here necessary? And how you actually can write it. All right? You don't need to answer me now, but just make sure when you study for the visitor, that's also part of the source you want to study. Right? It's kind of related to what you learned back in 2030, so I thought I can just assume it. But make sure you go over that. If you got questions, come to me. All right? But make sure you study for that. All right? That's the source code you want to study for checking the composite. Okay, and that's about it. All right. Any question you want to ask me about visitor in general before we move on back to syntactic analysis? All right. I presume everybody's okay? All right. Okay. So the last time, before we spoke about the composite pattern, this was the last slide that we went over until slide 32, which is about the dangling else problem, right? So you were supposed to think about why this particular grammar here can resolve the ambiguity from the dangling else, right? That's the last exercise I assigned to you guys to do, right? Think about it. If you want to have some discussion, come to my office hour. It's almost there for you. All right, so for the rest of the semester, I think mostly we're going to cover two important parsing algorithms. It's going to be the top-down parsing and also bottom-up parsing. So these are the two algorithms we want to cover. And your assignment number 3, the last assignment, that one there is going to be based on what we're going to talk about today, the top-down parsing, the initial sketch of the algorithm. That's something I will do. Robbie, question? The assignment, yes. You mean today, right? Assignment 1, yes. Each assignment will be graded. I will give you feedback, but you will get feedback about how you did for the attempt. But if you submit, you also got the full marks at the same time, right? Yeah, but of course you want to try your best to really do as much as possible. You don't want to just submit something that's really very partially done, right? That's the least you want to do, right? Good. Yeah, for your assignment number 3, you will see that after assignment number 2, it's going to be based on what we're going to talk about today for the top-down parsing. It's some very interesting programming challenge you will have to go through, right? That's nice. Okay, that'll be the last assignment. Okay, let me go over one slide just to have some concept about derivation. Basically, we want to link what you learned before about leftmost derivation and rightmost derivation and parse tree. What we did before, we did it on the paper manually. But we want to see algorithmically. Is it possible to say, given a grammar, given an input string, is it possible to really write some code to figure out the parse tree automatically or the derivation automatically? So that'll be the job for the 2 parsing algorithm we're going to learn. All right, so let's now take a look. Okay, this is what we did before. And just remember this symbol over here, right? We say, from the start variable of your grammar, eventually you can derive into some string p, right? And then you might take as many derivation steps as possible. For complicated string, for example, let's say it's an input program for your project. That's going to be like a very long string. How can you do it automatically rather than manually, right? That's a challenge we want to solve. Fortunately, it's been solved already. We just need to study the algorithm. All right, a parser is supposed to automate this derivation process. And there are 2 flavors of automated derivation. We do one after the other. What's going to be the input for the parser? That's kind of what you studied before. It's going to be a sequence of basically what you got from the scanner. You got some token, like a string, right? And also the syntactic category. But when we actually trace the parsing algorithm, we temporarily ignore the syntactic category. We don't need to worry. It should be quite obvious in the context. And of course, you need some reference grammar. Okay, that's the input. But we're going to see that more concretely in the next slide. And what's going to be the output? 2 possibilities. Either derivation exists, in which case you output an abstract syntax tree. Otherwise, you throw some error or throw some exception to say, I'm sorry, the string is not in the language. That's actually specified by the grammar, right? So either way, right? Nothing new so far. And in the process of constructing an AST for the input program, now we want to do a little bit of hand waving at the abstract level before we get into the concrete level, all right? So for AST, we got three things over here. We got the root, and if you recall back in 2011, right? I'm pretty sure you remember internal nodes and also leaves, right? I'm not going to check your knowledge about definition. Now, what we want to know is how would the AST correspond to the actual grammar and the actual string, right? Let me give you one example, okay? Let's say this is what we have. You can think about this is the input. Input number 1 and input number 2. We got a grammar from which we want to derive. And this is a string that we want to say if there exists a parse tree, return the parse tree. Otherwise, signal the error, right? But in this case, of course, we got a parse tree. What we want to see the correspondence is like this, just in general. Number 1, the root of the tree is the start variable. That one is so obvious. What about the leaves? A plus A times A. So these are all the tokens, right? Like a terminals. So these are the tokens or terminals. And what's in between? In between over here is the intermediate rule that we will need to apply as we go through the grammar. The intermediate one is a tricky one because in general, we simply don't know how deep we want to go to, depending on the string. All right, that's the general idea. That's why you will see here, the internal nodes will just be a subset of the variables. You can see what I just highlighted, turn, factor, also turn and factor. So these are the variables, right? You can see they're simply a subset of the variables. And what we'll see today for sure is to see when we do top-down parsing, starting from the start variable, how can we build the AST from scratch if there exists an AST for the string? That's something we'll see today, okay? But that's a general idea to understand first. And discovering the grammatical connections, basically what I'm saying is, you can see for every connection over here, all the connection here correspond to the rules we have over here. For example, expression can be substituted by turn. Oh, sorry, expression can be substituted by turn. You can see that corresponds to this rule. And then the turn can be substituted by turn, multiply factor. That's this rule, and etc. And we simply have to know how to really come up with all these connections and eventually get to the string at the bottom level. That's the tricky thing, challenging bit. All right, and there are two approaches to parsing that we're going to learn. Okay, so given some rule, and remember we got this notation before. Some variable can be substituted by a mix of the variables and terminals, right? That's the general rule production we have. And we got two things. We got two flavor. Either we go for top-down, or we go for bottom-up. Okay, we're going to do top-down today. Before I dive into it, we're going to spend at least 3 to 4 lectures on the top-down parsing, and then we go on to bottom-up parsing. I just want to give you some little bit vague, but a little bit abstract idea about how to distinguish between those. And then we're going to dive into detail for each one of them. Let's say for the top-down parsing over here, let's say we want to know whether or not there exists an abstract syntax tree for this string over here. The way it's going to do, well, obviously, since it's top-down, we're going to see stuff from expression over here. And if you see expression here, that's a tricky bit. In general, you can either go for this rule or you can go for this, right? And for now, it might be that we just have to go for this one here, in which case, it doesn't really match the ultimate parse tree. That means there is a possibility that you have to backtrack. Do you guys remember the term backtrack back in 3101? That means you're somehow doing some search. At some point, you reach some dead end. You found that maybe I should have made a different choice earlier in the tree. So I have to make another path. That's called backtrack. Okay, that's okay. If you don't understand, I'm going to explain backtrack in the algorithm itself. Okay, so you just have to know the main thing you want to understand for top-down parsing is the possibility of backtrack. And by the way, how do we implement backtrack? Which data structure do we use back in your 2011? Or to be more precise, if I don't want to have any recursive algorithm or recursive method in my code, I want to somehow simulate the recursion. How would I simulate it? What kind of data structure should I use to simulate the runtime behavior of recursion? What kind of basic data structure should I use? Should I use an array or should I use something else? You guys remember? Huh? Not linked list. Linked list and array, they're kind of linear. They're kind of like sequential from left to right, right? You're getting close. Okay, answer. William. Not that complicated. All right? You use a stack to actually backtrack for the backtracking purpose. You use a stack to actually remember the sequence in which you make the method call or make the progress. And then whenever you want to backtrack, you both go back to see which was my last choice made. So I can use the stack to keep track. All right, that's the conceptual idea. Well, we're going to get into concrete detail once we get there. All right, bear with me. That's about top-down parsing. I don't need to talk too much because I'm going to see that today. What about bottom-up parsing? It's the opposite. For example, we might start with just this. And then somehow we want to see what kind of characters should we combine next so that we can make a substring of the original string over here. And then eventually we want to build the tree bottom up. Okay, not very useful, but I think for the bottom up parsing, once we get to the detail, I'll show you the pseudocode. But you just want to remember, when we say top-down parsing, we start with the start variable. For the bottom-up parsing, we start with individual terminal and see how we can combine them into substring so that the subtree somehow can be combined together into the ultimate AST. That's the conceptual idea. All right? Alrighty. But we're going to do top-down parsing to begin with. Okay. Let me see. Okay, that's about the slide here. And let's dive into the algorithm right away over here. That's the entire algorithm, all right, over here. And I would suggest we proceed with this as follows. Okay. I'm going to go over the algorithm with you line by line. And then I'm going to try to make some notes about what each stage is roughly trying to do, make some visual if I can. And then we're going to trace 2 examples in total. And the third example will be left as exercise for you. After we have traced the first example, we'll take a little break to let everybody refresh a little bit, and then we'll do the second one. Okay, that's the plan for today. Okay. Let's now go over the algorithm quickly and have some conceptual idea what it is trying to do. Okay. Top-down parsing. Okay. We got input, we got output. What is the input for the parsing? You have some context-free grammar, and also you got some string, right? I didn't put it here, but you also got some string. Input string as well. Okay? What about the output? 2 possibilities. Either you're going to report this syntax error, or you simply return the root of the AST, obviously, right? So that will be the input and output. How do we achieve it? Okay? I'm just going to give you a little bit highlight remarks about what each block of code is trying to do. I can tell you that this will be the pseudocode you will have to base on in order to implement your solution for assignment number 3. Okay, so if there's any line you find a little bit weird, let me know. I can try to explain. But that's something you will have to make sure you understand. And this algorithm here, after all, is more like a pseudocode. It's not 100% complete. So there might be some implementation detail you have to fill in by yourself. We'll see some today as well. All right? Okay, let's now take a look. Basically, you can think about this part over here is about the initialization. This part over here. We initialize several things. The root and something called focus. You can think about focus is like a current pointer. What is the current root of the subtree that we're looking at? So that's the focus. And also, we're going to have some stack for the purpose of backtrack whenever we have to. Okay? And also, we're going to push some initial value and also the word. And this word here is similar to the scanner skeleton code that we went over earlier. Okay? And you can just see this particular line for now. A new node for the start variable. And this really corresponds to what I said just earlier. You can see here, in order to build an AST, the root is always no option, just a start variable. So what you do initially is simply just to create a node over here. Whatever the start variable is, expression, create this first. Everything else is going to be built underneath it. Okay? And the word over here, let's say, if we are reading, let's say, this particular input string, the first word is going to be just the parenthesis, first token, followed by token A, token plus, token A, token parenthesis, token star, and token A, and etc., one by one. We're basically turning a linear sequence into a nonlinear AST. That's really amazing. That's what we're doing. Okay? Let me make that remark over here. So we're basically transforming a linear input token sequence into a nonlinear AST. That's really the essence for the algorithm at a high level. All right, let's now take a look at the while loop, right? Over here. And you can see here, we say while true. But basically, as soon as we find some conclusion about a tree or about a string, we can just return. Okay. Right, so there are different conditions over here we have to worry about. Let me just highlight the conditions, and let's give some intuition before we start tracing them. One is about this, and then one is about this. And also, one is about this. Right, let's look at these three conditions over here. Okay, these three. This one here, if you look at that, so focus, remember, is more like the current pointer. If you went back to your 2011 when you learn about the linked list, the current is the pointer pointing to wherever cell you're looking at, right, for the traversal of the linked list. Similar function. If the focus right now is pointing to maybe somewhere in the AST, let's say somewhere, let's say here, and that particular focus is a variable, that means we need to do more work to find out which rule that we actually want to apply to build a tree. Right? That's all you need to know for now. Okay? So that'll be the first case. And we can subdivide into two cases over here. Okay? And I'll talk about these two more concretely when we get to the code tracing. Okay? So the first case will be if the focus is simply just a variable. Okay? And the second case is the focus is not a variable. Let's say the focus turned out to be, for example, is pointing to somewhere in the tree, but this component here, for example, is simply just A. And let's say A is really matching what we are expecting as the word right now. If it's matching, that means so far we're doing pretty good. We don't need to backtrack, so we can move on to the next word. Okay, that's the high-level idea, just for this one. All right, so that's the second case. What about the third case? The third case tells you a success. If the word is already the end of file, which means we have processed all the word, and so far there is nothing left off in the stack, meaning that there's nothing for us to backtrack. In that case, we are done. Just return the root. It's more like a success. And the final thing is, if none of the above have occurred, that means so far the path that we have chosen to do the production is not really reaching is not very promising. So we had to backtrack to try other path earlier. All right. It's a very high-level discussion, just so that you have some idea before we trace the code. Are we okay? Okay, good. Don't worry. I don't expect many questions at this point. Maybe you will have some question very soon. One more thing to say, and that's also going to be useful for you when you do the assignment later for practice. How do you implement backtrack exactly? That's something I will show you. Visually, it makes much sense. Basically, you have to do this operation related to the stack and also the tree. I will visualize it when we get there. For now, don't worry. Okay? And what we need to do now, before the break, I'll take the break and maybe a little bit earlier today. Actually, one example and also a little bit of housekeeping stuff, and then we'll take the break. Wouldn't take long. Let's try this first string. This string over here, that's the input. This is the grammar. And this is the algorithm that we just went over. We want to trace it. All right? Let's now try. And let's now try to do the following. Initialization. We want to initialize the root, initialize the focus, initialize the trace stack, and also push something into the stack, and also we want to initialize the word. So these are the things we're going to do. Let's do that. Okay? So we're going to have the root. So the root is going to point to some new node that's made from the start symbol S and just expression. So this will be the new node expression over here. Okay, straightforward. And then what about the focus? Well, focus in this case will just be the same, just the root. That means we start from the root, the focus, like a current. And we're going to have some empty stack called trace. Okay, empty stack over here called trace. And we only put null into it. You might be wondering, why do we put null rather than empty stack? That's something you can try to experiment in your assignments. I'm more or less using what I saw from the textbook to adapt it. So feel free to change it if you want to later. But let's stick with this version. And what about the word? Token by token. So the first one will be, let me put a word over here. And we are reading this one first. Just A. That's the word. Okay? Not too bad, right? Initialization. And let's now try to execute this part over here. And I want you guys to tell me, am I going to go to this branch, this branch, this branch, or this branch? 1, 2, 3, or 4? The first one. Because focus over here, expression is a variable. That's how you read it. As long as the current focus is a variable, that means we may have to visit some production. Okay, that's good. Thank you. So let's now take a look. So we're going to go in here. All right, and let's now read that further condition, which I didn't say before. How do we read this? This is to say, if there exists certain rule that says focus can be by certain variables or mix of the variables and terminal. Basically, this is a rule. This is a rule where the left-hand side is the focus. If there's such a rule, and the rule has not been visited before, think about that first search in your 2011 or maybe 3101. You kind of mark the nodes as either visited or unvisited, right? So if the node has been visited, you don't have to visit that anymore to avoid like an infinite loop, basically. Right? Think of that analogy. So this is to say, if there's any rule for which it starts with the focus, in this case, it's expression. In that case, we're going to do these. Okay? Number one, I want you guys to tell me, according to this grammar over here, is there any unvisited rule that starts with the focus? Indeed, right? This is one. This is one. That means we got two options over here. And of course, in the actual implementation, you might decide to store maybe all the production rule into a linked list, in which case this may come first before this one. In that way, you just explore the first one, right? Let's say. So what we'll do is we're going to explore this first one over here. And guys, I want you to pay very much attention to the color I'm using. I'm being very careful because when you implement the assignment number 3 for the parsing algorithm, when we say unvisited rule, it depends on which level you are in the parsing tree. For example, right now, we are now in level 0. Once we get to level 1, if this happens to be just another expression, in that case, it's a different level, level 1. We cannot consider this rule as being visited. We cannot. Because this one is only visited for level 0 purpose. For level 1, we got to start counting again. Okay, I hope that kind of makes sense to you. That means when you implement your assignment, just remember this little detail. Whenever you want to decide whether the rule has been visited, think about what's the context level. Are you in level 0, level 1, level 2, and etc. It depends on the level as well. Okay. All right, let's now go a little bit further. So we know that there is such a rule, and we choose this one here. And then let's now try to execute 1, 2, and 3. Okay? Don't be too terrified by the symbols over here. In some way, you make it very precise. Okay? So here we're saying if the focus over here is the expression, we got beta 1 all the way to beta n, depending on how many symbols and terminals you have. You can think about this guy here. Oh, let me just put it here. If you got expression over here, produces, let's say, expression plus turn. Think about this guy. Let me just use a different color. Think about this guy here is beta 1. This one here is beta 2. This one here is beta 3. And what the algorithm says, you're going to create beta 1, beta 2, all the beta as children of the focus. How do we do that? That means we're going to have here, here, and here, since we got beta 1, beta 2, beta 3. So that means we got expression, we got plus, and we got turn. Each one of them is a child node, right? Makes sense. And be very careful about this part over here. We want to push some child nodes into the stack. And do you see what's missing here? Beta 1. Beta 1 is not there. Do you see that? Beta 1 missing. And by the way, that's not a typo. It's intentional. Because once I get to beta 1, this will be the starting point for the next iteration as the focus. So that means beta 2 and beta 3, they will be handled later. I need to push them onto the stack. So that's why beta 1 is not here. All right? It's not a typo. It's intentional. All right? So what do? You want to make sure you push in a way so that this will be handled the next, and this will be handled the next. Right? So that means we're going to make sure we got, think about you're going to push in the reverse order. Push turn and push the plus. Okay? Push the turn and push the plus. All right? So far, so good. And shift the focus from the current one into beta 1. Focus is not here anymore. It's now going to be this one here. And we are now done with the first iteration. Any question so far? All right, let's do one more. I'm not sure if any one of you already spotted some problem. Some. Okay, let's do one more. We are now done with this branch over here and also this branch. So the rest will just be skipped. So we go back to the while loop, which is the while true, right? And the focus now is still expression, right? And which one, 1, 2, 3, and 4. Now, for the second iteration, which branch should we go into? Based on the focus. Anybody? 1. Yeah, because focus is a variable. So we should still go to this branch and do exactly what we just said for the first iteration. But now notice that it is so important to notice. This expression over here is level 0. And this expression over here is level 1. So when you want to judge to see if there's any unvisited rule, you want to judge from scratch, right? In that case, let me just do a little bit color change over here. When we actually were here, and we want to see which rule was unvisited, we look at these two. So I should have used the orange. Okay, beg your pardon. That's what I was supposed to do for the iteration 1. And now for iteration 2, since we are now in the blue, this level 1, is there any blue check mark for these two rules? No. So we still start with the first one. Okay, so now we're going to start with this one over here. That one there is going to give us expression plus and also term again, right? That will be basically creating the children and also push. Again, if you want to push, you're going to push the term, push the plus. And shift the focus from here to here. So this will be the result for the end of the second iteration. Do you guys see any problem now? It looks like we're going to keep doing this. Are we ever going to terminate? Not really, right? What you're going to do, if you follow this particular input string and this input grammar, you basically just got expression, 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 expression. Overstack problem. So the first tracing is pretty brief, but it's important to notice. It's not going to terminate. All right, number one, as intended. Non-terminating. And the lesson to learn about the parsing algorithm is this. The parsing algorithm itself is trying to find out the leftmost derivation. Attempts to find the leftmost derivation. However, the grammar itself is so-called left recursive. And how do we see that? Very quickly. I'm going to have another page to show to you. Expression here, you can see expression right away. It's recursion, the first one. That's why it's called left recursive. You're trying to have an algorithm which trying to find the leftmost derivation, but you got some input grammar that's left recursive. That's why it's never going to terminate. All right? That's some lesson we have learned. Now, how can we fix this problem? Apparently, we got two choices. Either we change this maybe to finding the rightmost derivation, but in that case, we got to watch out, because if the grammar itself is right recursive, then we're going to suffer again. So what we're going to do is, there is a procedure which we'll talk about next Tuesday, not today, which is to say, given a grammar, we can remove the left recursion so that the grammar itself will be suitable for this algorithm over here. That's something we'll do on Tuesday. But what we'll do today instead is to give you a grammar that's not left recursive. That's something we'll see. Okay, let me recap. The parsing algorithm that we have just seen is trying to find the leftmost derivation. So if the input grammar is left recursive, you're going to end up having things like this, which will never terminate. The way to resolve it is by removing the left recursion. And then we will be able to trace. So that's why this trace is pretty quick, because we quickly realize it's never going to terminate. All right? And let me say a little bit more, and then we'll take a break. Okay, so that's about infinite loop. And then what we want to do now is to consider this grammar over here. All right, this grammar here, you can take it for granted just for now. This one here is called right-recursive grammar, which would be suitable for that left derivation finding top-down parsing algorithm that we just talked about. Okay, this one here. Before that, let me just talk about this page here. I think there's one page I want to show to you. Give me a moment. Okay. Okay, here. Let's define the left recursion first of all, and then I'll get to that right recursive grammar. What does it really mean for the grammar to be left recursive? It can be either directly left recursive, or it could be indirectly left recursive. Either way, it's not good. Okay, let's take a look. Basically, as long as you can define as long as you can identify some cycle, it will be recursive. This one is rather easy to see, the directly recursive one. You can see here, we got expression here, expression right away. For example, you got turn here and turn right away. That's directly left recursive. That one's obvious, all right? What about indirect? These two are indirectly left recursive. Okay, anybody see why? That means you might have to move between the rules before you can see that. For example, we start with A. A can be replaced by, first of all, B. B itself can also be replaced by C. C itself can also be replaced by A. So it's as if you put A here. Agree? Okay, guys, that's really indirectly left recursive. And I want you to do me a favor. If you go to the slides, you will see that this is the precise condition for indirectly left recursive. Okay, I'll mention that very briefly, but you got to study that carefully. If you're able to say A derives into certain variable here, let's say B, and B takes several derivations to get back to A. In that way, you got a cycle. So that's indirectly left recursive, right? And can we just try this one here very quickly? Would that be indirectly left recursive? This one here. For example, A can be replaced by B. By the way, you wouldn't go in this way because that would be replaced by terminal and never it's already terminated, right? A replaced by B, B replaced by C, C replaced by D, D replaced by A again. All right? So you just gotta look for the symbol. I'll mark it down. A replaced by B, C, D, and then A, right? Left recursive. Okay? Either way, it's not good. If you notice that, I ask you to trace using that top-down parsing algorithm. And you see the grammar itself is actually left recursive. Don't even try to trace it because you'll never end. That'll take out all your test time. So you want to just, your answer should be, it's not going to terminate because blah, 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 right? All right, hopefully that's clear. And one more thing before we take a break, please, one more thing. Now, what we want to do is to remove the left recursion. There is another algorithm that we need to learn, how to remove the left recursion. That's not something you have to worry for your assignment number 3. For assignment number 3, you can assume whatever input grammar I give to you is not going to be a left recursive, either indirectly or directly. But you ought to know how to do it. Okay? So for today, we'll just give you the right recursive grammar directly. Take it for granted and see how the tracing can be done. That's what we'll do. All right, so guys, this will be This is the left recursive grammar, and that's the parse tree. And these two things are pretty familiar to you. We did it already in class, right? Now what I need you to try, okay, if you grab a paper, that'll be nice. This is so-called a right recursive grammar. Because, for example, you can see expression prime, right? Is right recursive right away, okay? Now, can you draw the parse tree just for this one here? This will be very important because after the break, we're going to trace to see how the top-down parsing algorithm is going to find out the parse tree that you're going to draw right now on this grammar. Okay? It's not exactly like the kind of parse tree you would think it looked like usually. Why don't you guys try? And then we'll go over the answer, and then we'll take a break. Okay? This string here and this grammar here. Okay? Give it a try to see what a parse tree should look like. I'll give you guys 2 minutes or 3. Okay, I already got my answer. I did my homework before today's class. I can copy and paste it right, in 3 minutes. So you can also compare the standard answer. But you guys better try first. You might find it a bit weird. For example, epsilon. That means the variable you choose can be replaced by just epsilon, right? It's one of the alternatives. You might find it useful. All right? And I'll speak a little bit more about epsilon after the break. Okay. Hopefully it's not too difficult. Take another 1 minute or two, and then I'll paste the answer on the page and go over that quickly, and then we can take a break. Okay. Okay. Why don't we just take 1 more minute, and then I will go over the answer with you. Okay, another 20 seconds. Somehow these two grammars are equivalent to each other, but one is left recursive, the other one is right recursive. Right? One is suitable for the algorithm trying to find the leftmost derivation, the other one is not. Right? That's really what you have to remember. All right, let's take a look at the answer. Let me go to the page. Oh, not here. This wrong way. Here. All right. Let me copy that. All right. Just to save some time. Copy. All right. And this is what you were supposed to get. Am I correct? No?
You're missing one thing on the end of your expert prime.
I did?
On like the third level.
You mean level 0, level 1, level 2, level 3?
Level 2,
Level 2?
way at the end, expert prime, it should probably lead to an epsilon.
Yes. Oh, thank you. I see what you mean. Yeah, you might be right, William. Let me double check so I don't paste anything that's wrong. Thank you. That one there, it should be epsilon. Yeah, it should be right. Yeah. I didn't really finish that example when I did it today. Thank you. So expression prime would just be epsilon. Absolutely. So that would be just like that. All right, let's now go over that very quickly together with you. Okay, so once you get a tree, if you look at the leaves, A epsilon plus A times A, epsilon here and epsilon. Altogether, epsilon has no effects. You got A plus A times A. That's a parse tree. All right. If you haven't got it right, try to practice this. You might have a question like that. And I can tell you that this is one of the test cases for your assignment number 3. Right? I think it's really a nice programming practice to see how to turn the linear into nonlinear. That's a really good practice. All right? Guys, do you have any questions so far? Okay. Let's take attendance, and then we'll take a break. All right. All right, let me already refresh my location, so that will also save time. As soon as it's launched, I will be able to launch the poll. 43. Oh, I want to start the class. And then the poll. All right, and select. All right, guys, you can go ahead, check in. If you got trouble, as usual, come right to the front. I can definitely see we missed one from today. I can definitely see. We don't have that many girls, so I kind of recognize the faces. I know which one we are missing, but that's okay. All right, everybody got their self-check-in? Go. All right, I'm gonna stop it. Would that be okay? You fine? All right. All right, let me stop it. Okay, guys, just before we take the break, let me tell you the plan. We just have to trace this input over here. When I taught this course back in the winter 2020, it took me to really explain in detail the complete tracing. It took me about 15 minutes. We don't have that much time, which is good for today. What I will do is, after we take the break, until we have to end the class today, I'll do as much as I can, as clear as possible, so that you can complete the rest. So this tracing here really shows you the essence about how backtrack, how things work for this algorithm. That's something you must know. I'm sorry, it's going to be very boring. Everybody might just be dead by the time we end the class today, but just the way it is. Just get through it. All right? Take a break for 2 minutes, and then we'll come back. Yes.
So for our project, we have a question. So for the final project, we want actually.
You mean the final summation?
Yeah, for the final, like more or less, yeah. But like for the output, we want to kind of dump all of the coverage into like a JSON like output, and then in the HTML file, like use that to like generate like the page.
That's okay. So as long, I can tell you that as long as the output has a starting point index.html, as long as that's the case, how that HTML file might run behind the scene doesn't matter.
Yeah, I guess the only like weirdness there is that I think they want to use a Java library to generate the JSON. That's allowed, yeah.
That's a good question.
Because like otherwise, right
Yeah.
now, like we kind of have to do it like this weird way, like kind of like make.
How about this? Have you guys started already using that JSON library? Oh, you need that. Okay. How about this? I would suggest for it sounds to me it should be okay just to generate a JSON. How about this? For milestone 1, use it. and then make sure you mention how you use it to me, maybe on the milestone 1 meeting, and then we can take a look. Okay. It should be okay. Should be okay. Yeah. Go for it. It sounds good. All right, I think we should resume. All right. Okay. All right. So in terms of the slides, yeah, so in terms of the slides, I think for today we'll cover until 37, just to let you know. And what we just went over, just to show you guys, so we tried the one that wouldn't terminate before the break, right? That's what we tried. Make sure you know why. And there will be 2 more string you should really practice. I'll practice the first one together with you a bit. We got about 20 minutes left for the class, which is good. So we should do no more than 20 minutes on this. It's pretty dry and boring. You just got to be very careful. I would say try to picture how you would do it. I might ask you questions, assuming that you know how to trace it. I might ask you some detail about the tracing in the quiz or in the exam. Okay, so but I'll try to do as much with you as possible for today. And this is something we'll do partially together. And this is a little bit more challenging string to parse. That's something I'll leave to you as your own exercise. If you really want to show me your work about tracing it, again, office hour. Otherwise, I'll assume you're fine. All right? Okay, good. And there will be something about epsilon production. So what do I mean by epsilon production? If you look at this grammar here, which we're going to assume will be the input. For example, you see expression prime produces epsilon. If the epsilon is the only right-hand side, it's an epsilon production. Okay? And how do we exactly handle epsilon production in the grammar? That one there is not explicitly mentioned in the algorithm. But I'm going to show you visually how that's supposed to work. We'll at least cover that. All right? That's kind of something you want to remember. Okay, why don't we try? All right. I did try to practice earlier this morning. I can still mess up. But anyway, I'll try to demonstrate as much as I can. But let's try. Help me out if I make any mistake. This is the input string. This is the right-recursive grammar. And that's the top-down parsing algorithm trying to find the leftmost derivation. Right? Let's now try. Initialization, we did it already. Let's do it again. So we're going to do this part over here. Initialization. Start with the root. So the root is going, let me just save some space. The root points to the node created from the start symbol, which is expression. And the current node to focus will just be the root. And of course, we'll keep changing the focus. Initialize the trace stack for backtrack purpose. And I already drew the stack. I just call it trace. And we're going to push just a null value there initially. And then we're going to have the word. I'll put a word here. And let's say here we start with this, just A. Okay, that's the initialization. We're good. Okay. And actually, we already did some very nice warm-up before the break, right? So everybody would agree. For the first iteration over here, we are actually going to satisfy this condition, right? Because the focus is at a variable. Okay, so we're going to go into here. And when we get into this nested if condition here, should we go for this one here or should we go for this one here? It depends on, at level 0, have we explored all the possibility for expression produces something? We haven't, because this one is still not visited. So that will be the one to look at, right? So that means we're going to go into over here. So the way I'm going to do it is I'm going to use a different color. So I'm going to use the blue. So that means I'm going to visit this particular rule, all right? And to do that, it's going to be turn and expression prime. So remember the 3 lines we need to execute over here. Create the child nodes first. It's going to be turn and also expression prime here. And we have to push onto the stack. What do we push? Do we push expression prime and turn? Just expression prime in this case, right? Think about the reverse order, okay? That's something we did. So push expression prime first. And the focus is going to be turn, beta 1. So think about focus rather than here, it's now going to be here. And now you can see we are facing a different situation now. Before we enter the second iteration, let me mention. It's now turn rather than expression again. So indeed, it's going to terminate, right? It's not left recursive anymore, okay? That's about the first iteration. What about the second iteration? When we go back to the second iteration, while true, so we just check to see, is this condition satisfied again? It is, right? Because focus is turn, which is a variable. So let me use maybe green. Okay, for the turn, it's actually here. This is the only rule that we can use. Sorry, I'm not sure if you can see that very clearly from the screen. But this is blue, this is green. Okay, but you will see that when you see the recording if needed. Okay, so for this one here, we're still going to execute 1, 2, and 3. 3 lines over here. That's going to be turn will be factor and turn prime. Factor and also turn prime. And that's about this first step. What should we push onto the stack? Turn prime, right? Let's do that. And then we're going to change the focus into factor, okay? Over here, so far so good. And then for factor, we can go to the third iteration. Let's say we go to the third iteration here, and because now it's factor. Factor is definitely a variable. So we're still going to execute this part here again. Okay? And let's go further. And for the factor here for level 2, we should try this one first. Agree? And you can see that we are reaching somewhere that's going to require backtrack. Because from our judgment, we should really choose this one rather than this one. But the algorithm wouldn't tell that at this point. So you're going to try this one here. Somehow we're going to reach some dead end and know that we have to backtrack. So now we want to see what happened. So after choosing this rule, we're going to execute 1, 2, and 3. Let's create a child nodes. This one here, expression, and this one here, okay? And we're going to push some stuff onto the stack. What do we push? What's the first one to push? Yes, and then? Thank you so much. Exactly. And then we're also going to shift the focus from this to this, all right? Good. And let's now move on to the next iteration. Now, can somebody tell me what's now going to happen? Given that focus is now not a variable. I'll make it a little bit larger for you guys. Okay, so somebody tell me what's going to happen here. Apparently, the first if condition there, focus is a variable. It's not going to be true. Agree? And William, where should we go?
Well, we can check if the word matches focus, and that's not true.
Right. How about the next else if?
And we have to null, so I think we can backtrack.
Exactly. That's exactly right. But let me just emphasize that again to everybody else. Very good. Right? This is the current focus. Not a variable. Also, does it match the word? No, it doesn't. This does not match this. And also, is it the EOF? No, not the end. So backtrack. All right. So now, how do we backtrack? Let's now go over that code over there a little bit more carefully. Okay. I put that in a little bit like unprecise words, but I think once I show you the visual, you will have to figure out how to do that accordingly in the programming. Okay. I say pop from the stack all the siblings of the focus. The sibling of the focus will be these two. Pop them off. That's what I meant. Okay, let's do that first. So we're going to pop these two off because that's the wrong end to go. And also focus will be assigned to focus the parents, meaning that we want to have the focus reassigned to the factor, which is the parents of this one here. And then reset the children, meaning that we're going to reset all of them. They're gone. And for your record, I'm actually going to put this guy onto over here so that you remember. Think about they are just being garbage collected, okay, somehow. Okay, I'm going to put it here so you will remember. Okay, and then, okay, now, and we'll go to the next iteration. Now, can somebody tell me, in the next iteration, we got focus pointing to factor again. Now, what's going to happen?
We're going to go to the second rule for factor.
Okay, so you mean this one here?
No.
Oh, the second rule, yes. Okay, that's true. Okay, but I agree with you, but let me just go over the process just with everybody else. First of all, the focus is, again, factor a variable. So we go to this check. And notice that for this particular level, we just explored this particular rule. Agree? You can see the color here is matching, right? That means we have one more to explore. If that one also doesn't match, we'll backtrack further. But let's try, okay? So we're still actually going to go for that one. So let me just say, we're going to check for this one here. Try this one here. And then we're going to go for 1, 2, and 3. And notice that you can see for the green one, I got 2 times. The first time we tried this, the second time we tried this, right? So now let's try the second time. That one is going to simply just got A. You can see this one, only one child. So beta 1, only beta 1 is there. And should we push anything onto the stack? No, there's no beta 2. Okay? And also focus is now going to be here. Okay, over here. All right, A here. And again, any volunteer to tell us what's going to happen given that focus has been now shifted to A. Anybody? Oh, okay. Go ahead. Yep, absolutely. First of all, A is not a variable, so skip the rest here. Also, the word currently is A, is matching the focus. Yes, indeed. We're going to go for this one here. Very good. Okay, let's do that. And once we do that, let me use purple here. So let's say we're going to try the word and focus, right? So the word is now going to be the next word. After A is going to be the plus. All right, and then the focus is going to be trace.pop. Trace.pop is term prime. That makes sense. That means the focus is now going to be shifted to over here. Okay, so far so good. Okay, I would say let's go a little bit further. I will pause once we have handled the epsilon production. That's what we will do. Okay. And so now we got we got a term prime. Okay, good. What about the term prime? I'm going to do it completely with you, but just before that, can we just try mentally to be predicting what's going to happen? The focus has now been shifted to term prime. Can you guys predict what's going to happen, given that there are 2 rules for term prime? If you guys can get this sorted, and once I trace, I think you got it. William.
I think we're going to try the start factor from prime
and then get the epsilon. All right, good, absolutely. Guys, why don't we do that for completeness? So once I handle the backtrack once again, and I will tell you how to handle epsilon, and then we're done. All right, so for the rest can be up to you. We don't need to do the whole thing. Let's try that. So given that the focus is now here, so we're actually going to, again, go for this part over here, right, this part here. And the term prime has two alternatives. Let's try the first one here. That's going to be star factor and also term prime. And obviously, we should push term prime and factor. And the focus now should be shifted to here. That will be the end of this iteration. And as William correctly pointed out, when we go to the next iteration, with the focus being a not variable, in that way, again, it's not a variable, so we skip the rest for the if. And then we can see that that one there doesn't match the word. Right? You can see star does not match the plus. So we skip this part here. And the star is also not, the plus over here is also not an EOF. So we also don't execute that. So we have no option but to backtrack. Okay, second backtrack. For this backtrack here, again, we're going to pop off the siblings. The sibling for the star will be factor and term prime. Pop them off over here. And then the focus should be shifted back to the term prime. So here, it's not there anymore. The focus is not going to be term prime again. And I'm going to just move this guy here to over here for you. That's the second backtrack we did. All right, second one. And you can see now the focus is term prime again. All right? Jordan, if you don't mind, I point you. So now focus is term prime. What should we do in the next iteration? The first row? I agree. Epsilon. Thank you. I agree. Good. Very good. So for the next iteration, we are still actually going to try the term prime. So we'll try again. Again, purple, 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 right? Again, the first time we tried the first rule, we actually got backtrack. So that's why we got to try the second time. And this time now, we are actually going to have a, let me use a final color here, epsilon. All right, so for the epsilon here, we have to handle that a little bit differently. Okay. And by the way, just for your information, what we have done so far, let me highlight. Expression, term, expression prime, factor, A, term prime, epsilon, right? So that's what we have done so far. If you look at the parse tree that we did before the break. Partially. We're getting there. So I'm going to talk about how you can handle epsilon once you see that in the algorithm. The rest, exercise for you. Okay, but I think you guys definitely got the idea. Okay, let's now talk about how to handle epsilon. And this is something not really explicitly said in the algorithm. So I will point to you to the slides. And actually, just visually, how would you suggest? How should we handle the epsilon? Should we backtrack? William, you said no. Is there any intuitive judgment or justification why we wouldn't want to backtrack?
Well, I guess because there's
Sorry, say that again. What do you mean? I'm pretty sure there's something else we need to do, but not exactly the rationale. Okay, I'll help you a little bit. What was the reason that we did the two backtrack earlier? Remember we did this backtrack here? We did this one here, we did this one here. The reason we did it was because somehow this didn't match A. And also this didn't match plus. Can we really say that epsilon doesn't really match the word over here? Not really, because how about I'll put it this way. It is true epsilon is not exactly plus, but you cannot deny there is a possibility that maybe this symbol over here can be reduced somehow to plus. And the epsilon has no effects on the concatenation. So that's why we wouldn't want to touch the epsilon just yet. We may have to, but not at this point. All right, do you guys see the justification here? Okay, I'll write it down, and then I'll show you what to do. Okay, so this part here. Does it match plus, but epsilon has no effects on the concatenation? That means the next symbol may match the word. That's my intuitive justification, right? Just keep that in mind when you implement your Java code later. Right, so that's why in the slides you will see how do we handle. We simply say execute, focus will be trace.pop. What does that mean? That means we don't want to modify the tree structure over here. We don't want to. Okay, we don't want to. We just want to change the focus to this guy here. What's this guy? Exactly expression prime over here. Okay, that's exactly there. Okay, that's what we want to do. Okay. After this, we just want to do that, the focus. And you guys can do the rest. The rest of the tracing, I know it's tedious, again, tedious, error prone, and very nice way to put you into sleep, but you gotta try, okay? Exercise. Okay, and I would say this is part one of the exercise. There is another string over here, which will be a little bit more challenging. You will see that this one here might require, I don't know, more or fewer. You gotta try, more backtracking, right? That's also exercise for you. If there's any part you want to go over with me, feel free to come by office hour. Otherwise, I will assume you guys are okay. Okay? All right, I'm finishing just 1 minute earlier today. All right, do you guys have any question? I'll try to limit this kind of tracing to just 1, maximum 2 for each class, because you guys need some time to digest. All right? You guys can take 1 more week to digest this before the assignment is released. Question? Sorry, say it again. A solution? Oh, you mean the epsilon trans? There's no. Because this code here, I want to keep it as simplified as possible. So that's why I mentioned in the slides about how you're supposed to handle the epsilon production. Just make sure you have some special rule just for the epsilon production. Yeah, good. Guys, thank you so much. And then I will see you next week.